Welcome to a journey through the cosmos. Today, we delve into the exciting world of the search for extraterrestrial intelligence, or SETI. Imagine for a moment the vastness of the universe, with its countless galaxies, each teeming with billions of stars. Now consider that around many of these stars, planets orbit, and on these planets, life as we know it could exist. This is the vast cosmic stage upon which SETI operates. The SETI project is a concerted effort by scientists around the globe, united by a common purpose: to find out if we are alone in the universe. The history of SETI is a fascinating tale of human curiosity and scientific progress, dating back to the early 20th century when radio technology first allowed us to listen to the stars. But why do we search for extraterrestrial life? Is it mere curiosity, or is there a deeper significance? The search for extraterrestrial intelligence is more than a scientific endeavor. It is a testament to our desire to understand our place in the cosmos. It challenges our notions of life and intelligence and forces us to question what it means to be human. The goal of SETI is not to find alien creatures or civilizations, but to detect signals that indicate the presence of technology. These signals, whether they be radio waves, light signals, or other forms of electromagnetic radiation, could provide undeniable evidence that we are not alone in the universe. The significance of such a discovery cannot be understated. It would not only revolutionize our understanding of biology and evolution, but would also have profound implications for our philosophy, religion, and culture. It would mean that in the vast cosmic ocean, we are not solitary islands, but part of a larger cosmic community. As we set the stage for our cosmic journey, remember, we are not searching for little green men, but for signals that show us we are not alone in the universe. The first steps towards the stars weren't taken with rockets, but with equations and radio waves. It was the mid-20th century when the search for extraterrestrial intelligence, or SETI, really began to take shape. This was a time when humanity was just beginning to explore the cosmos, but our curiosity was already reaching out to the stars. In the early days, SETI was all about listening. It was about tuning our technology to the cosmos, hoping to pick up a signal that could not be explained by natural phenomena. We were looking for a hello, a cosmic handshake from a civilization far more advanced than our own. The Drake equation, named after the astrophysicist Frank Drake, was one of the first serious attempts to quantify the odds of finding such a civilization. The equation takes into account factors like the rate of star formation, the fraction of stars with planetary systems, the number of planets per system that could potentially support life, the fraction of such planets where life actually develops, and the lifespan of a technologically advanced civilization. But the Drake equation is more than just a mathematical exercise. It's a statement of optimism, a belief in the potential for life beyond our tiny blue dot. It gives us a framework to think about the cosmos and our place within it. It's important to understand that the Drake equation doesn't give us a definitive answer. It's not a crystal ball that tells us how many alien civilizations are out there. Rather, it's a tool for framing our understanding and guiding our search. Each term in the equation is a piece of the puzzle, and as our knowledge of the universe expands, so too does our understanding of these terms. The Drake equation may not have given us an exact number, but it does show us that the possibility of intelligent life beyond Earth is far from zero. As we continue our search, we keep this in mind, ever hopeful that one day we might finally make contact. From equations to emissions, SETI's search has always been about signals. In this fascinating journey of exploring the cosmos, radio signals have held a pivotal role. They are the messengers from the outer space, carrying information from the farthest corners of the universe right to our doorstep. Radio telescopes play the crucial part of being the receivers of these cosmic postcards. These aren't your typical backyard telescopes. Imagine a colossal dish as big as a football field pointed towards the sky, listening. They catch radio waves, transforming them into data that scientists can decipher. One such radio telescope at Ohio State University had an unusual story to tell back in 1977. While routinely scanning the skies, it picked up a signal that was loud and clear, yet out of the ordinary. This wasn't just another signal. It was a signal that stood out from the cosmic noise, a signal that was so strong that it was almost like someone shouting in a whispering crowd. The signal lasted a mere 72 seconds, but its impact was everlasting. It was so significant that the astronomer on duty that night, Dr. Jerry Amon, couldn't help but jot down "wow" next to the data printout. Hence it came to be known as the "wow" signal. The "wow" signal was unique. It was a narrowband emission, exactly what scientists would expect an interstellar broadcast from an extraterrestrial intelligence to look like. But despite numerous attempts, the signal was never detected again, leaving its origin a mystery. The "wow" signal thrust SETI into the limelight, sparking interest and debate worldwide. It pushed the boundaries of what we thought we knew about the universe and our place in it. It emphasized the fact that we are not just passive observers, we are active participants in this cosmic journey, constantly seeking answers. While the "wow" signal remains unexplained, it serves as a reminder that the universe is full of surprises, and as we continue our search, who knows what else we might uncover? The universe, after all, is a vast place, and as the "wow" signal has shown us, it's anything but quiet. A SETI search isn't limited to radio waves. The universe communicates in many ways. Imagine trying to listen in on a conversation happening across a noisy room. That's a bit like what SETI is doing, but instead of a room, it's the entire universe. And rather than voices, we're tuning into radio waves. But what if we've been overlooking other forms of cosmic chatter? That's where optical SETI comes in. Optical SETI, or OSETI, focuses not on radio waves but on pulses of light. This approach is based on the idea that extraterrestrial civilizations might use lasers or other high-energy light sources to communicate across the vast distances of space. Compared to radio waves, light waves can carry more information and are less likely to be absorbed or scattered by interstellar dust and gas. But optical SETI isn't without its challenges. Detecting these light pulses requires incredibly sensitive equipment and clear, dark skies. Even the blink of a cosmic eye could mean missing a potential signal. Now let's shift gears from light to something a bit more mysterious: fast radio bursts, or FRBs. These are intense flashes of radio waves that last only a few milliseconds. They're sort of like cosmic lighthouses, sending out brief but powerful signals that we can detect here on Earth. FRBs were first discovered in 2007, and they've been puzzling scientists ever since. We still don't fully understand what causes them. Some theories suggest they might be the result of cataclysmic cosmic events, like the collision of neutron stars. But could they also be intentional signals from advanced civilizations, like cosmic SOS messages? That's a question SETI researchers are eager to answer. As we continue to probe the universe, we're realizing that our search for extraterrestrial intelligence isn't just about listening. It's about looking too. From the faintest glimmers of distant stars to the sudden flash of a fast radio burst, every bit of light and every wave of energy is a potential clue in our cosmic detective story. From radio waves to light waves, the cosmos is full of signals waiting to be discovered. In the vast cosmos, there are places where life could thrive, just like Earth. These places exist on exoplanets, planets that orbit stars outside our solar system. The discovery of these celestial bodies has been a game changer, not only for astronomy, but also for the search for extraterrestrial intelligence, or SETI. The first exoplanet orbiting a sun-like star was discovered in 1995. Since then, the tally of known exoplanets has skyrocketed into the thousands, thanks to missions like NASA's Kepler and TESS. These exoplanets come in all shapes and sizes, from gas giants larger than Jupiter to rocky planets smaller than Earth. But not all exoplanets are created equal when it comes to the potential for life. This is where the concept of the habitable zone comes into play. Also known as the Goldilocks zone, it's the area around a star where conditions are just right, not too hot, not too cold, for liquid water to exist on a planet's surface. And where there's water, there could be life. Now, finding an exoplanet in the habitable zone doesn't guarantee the presence of life. There are other factors to consider, like the planet's atmosphere and its geological activity. But it's a start, a clue in the cosmic haystack. SETI researchers pay close attention to these potentially habitable worlds. They use powerful telescopes to listen for signals that could indicate technological activity. Any sign, no matter how faint, could be the telltale sign we're not alone in the universe. So every new exoplanet discovery is a cause for excitement. Each one represents a new world to explore, a new possibility for life beyond our solar system. And while we haven't found ET yet, the search is far from over. With each new exoplanet discovery, the chances of finding a cosmic neighbor increase. As we continue to gaze at the stars, we're reminded that we are but a small part of a vast, complex, and possibly life-filled universe. Scene script. SETI's search isn't a solitary endeavor, it's a quest that everyone can join. In the late 90s, SETI researchers came up with an ingenious idea to harness the power of the global community. The project was dubbed SETI at Home, and it was designed to tap into the unused computing power of personal computers around the world. Imagine every computer as a small research station. When these machines are idle, they're not doing much. But what if they could be put to work during these down periods? That's the premise behind SETI at Home. This project uses a form of distributed computing, an approach where a large computational problem is divided into smaller tasks that can be solved independently. Users who sign up for SETI at Home download a special screensaver. When their computer is idle, the screensaver kicks in, and the machine starts analyzing data from radio telescopes. Each user's computer sifts through a small portion of the data, looking for patterns or signals that might indicate extraterrestrial intelligence. But SETI at Home doesn't just leverage your computer's processing power. It also taps into your human intuition and pattern recognition skills. This is where citizen science comes into play. Citizen scientists are ordinary individuals who contribute to scientific research in their spare time. They might not have formal scientific training, but they possess a wealth of untapped potential. Their keen eyes and unique perspectives can sometimes spot things that algorithms and automated systems might miss. Since its inception, SETI at Home has attracted millions of volunteers from around the world. These citizen scientists have collectively contributed an immense amount of processing power, equivalent to some of the world's most powerful supercomputers. And while we haven't found ET just yet, every day these volunteers are helping to sift through the cosmic haystack in search of that elusive needle. In a sense, SETI at Home democratizes the search for extraterrestrial intelligence. It takes the quest out of the hands of a select few and places it into the hands of the many. It invites us all to look up at the stars and wonder, is there anyone out there? With SETI at Home, anyone can become a part of the cosmic search. In SETI's quest, the Breakthrough Listen initiative is leading the charge. Breakthrough Listen is a pioneering 10-year research program launched in 2015, dedicated to finding evidence of civilizations beyond Earth. It's the largest ever scientific research program aimed at finding evidence of civilizations beyond Earth. Funded by the Breakthrough Initiatives, led by internet investor and science philanthropist Yuri Milner and physicist Stephen Hawking, it's a global effort that's pushing the boundaries of what we know and what we can detect. The initiative is unique in its approach. It's not just looking for radio signals, but a wide range of signals across many frequencies. It's like tuning into the cosmic radio and scanning through every single station, hoping to pick up a signal that's out of this world. Breakthrough Listen uses some of the world's most powerful telescopes, scanning 10 times more of the sky than previous programs. It's also able to scan at least 5 times more of the radio spectrum and do it 100 times faster. But it's not just about the search. Breakthrough Listen is also about sharing. All the data collected is available to the public, allowing anyone to join the search. It's a truly global effort, democratizing the search for extraterrestrial intelligence. So far, the initiative hasn't found definitive proof of extraterrestrial life, but that doesn't mean it hasn't made significant strides. It's discovered dozens of new fast radio bursts from galaxies billions of light-years away, and it's identified several signals that have sparked interest, although they've yet to be confirmed as extraterrestrial. The Breakthrough Listen initiative is also involved in ongoing projects. It's currently conducting a detailed survey of the 1,000,000 closest stars to Earth and the 100 closest galaxies. It's also scanning the plane of our Milky Way galaxy and the galactic center, listening for signals that might indicate the presence of advanced civilizations. Breakthrough Listen is expanding our search, listening for the whispers of the cosmos. Life leaves a mark, not just on Earth, but potentially on other planets too. This mark, or signature, that life leaves behind is what astrobiologists refer to as a biosignature. So what is astrobiology? Quite simply, it's the study of life in the universe. It's a field that converges biology, geology, physics, and astronomy to understand if life exists beyond our planet. But how do we search for these elusive biosignatures? It's much like a cosmic detective story. The key lies in understanding that life interacts with its environment in specific ways. For instance, on Earth, plants produce oxygen through photosynthesis, leaving a significant concentration of oxygen in our atmosphere, a clear biosignature. Astrobiologists are looking for similar signs on other planets. They're particularly interested in exoplanets, planets outside our solar system, especially those in the habitable zone, where conditions might be just right for life as we know it. One of the primary techniques to identify these biosignatures is through the study of a planet's atmosphere. When a planet passes in front of its star, some of the star's light filters through the planet's atmosphere. This light carries with it a spectral fingerprint, which can reveal the gases present in the atmosphere. By analyzing this spectral data, scientists can detect potential biosignatures such as methane, oxygen, or even more complex organic molecules. Another method involves studying the surface of planets for signs of life. This could be anything from the presence of liquid water, certain mineral formations, or even large-scale structures that resemble the effects of biological activity on Earth. The search for biosignatures is not just limited to planets, though. Moons, asteroids, and even interstellar clouds are all potential sites where life's signature could be found. Remember, though, that the detection of a biosignature is not definitive proof of life. It merely suggests the possibility, a tantalizing hint that we may not be alone in the universe. Biosignatures could be the breadcrumbs leading us to extraterrestrial life. And that's a journey worth taking, don't you think? The road to discovery is not without its obstacles. The search for extraterrestrial intelligence, or SETI, is no exception. Researchers in this field face numerous challenges, the most obvious being the vastness of space itself. We're searching for a needle in an infinite haystack, so to speak. And even if we manage to detect a promising signal, there's the Herculean task of interpreting it. After all, we're dealing with potential civilizations that might think and communicate in ways far different from us. Another major roadblock is the sheer cost of these endeavors. SETI research requires advanced equipment, significant manpower, and immense energy resources. Funding is a constant struggle, with much of the financial support coming from private donors and organizations. The limitations of our technology also pose a considerable challenge. Our methods of detection are currently restricted to what we know: radio signals, optical signals, and the search for biosignatures. But who's to say that extraterrestrial civilizations aren't using a form of communication or leaving a type of signature that's beyond our comprehension or detection capabilities? Despite these challenges, the future for SETI is bright and brimming with possibilities. As technology continues to advance, so too will our methods for searching the cosmos. We're already seeing this with the development of machine learning algorithms designed to sift through SETI data more efficiently. Additionally, the emergence of new scientific fields like astrobiology is providing fresh perspectives and tools to aid in our search. The increasing discovery rate of exoplanets, especially those within habitable zones, also offers exciting new avenues for SETI research. In terms of methodology, there's a growing emphasis on multidisciplinary approaches. SETI researchers are collaborating more with astronomers, biologists, chemists, and even social scientists to better understand the potential nature and behavior of extraterrestrial civilizations. Despite the challenges, SETI's quest continues, driven by our curiosity and our hope for discovery. And who knows, maybe one day we'll finally find that elusive cosmic needle in the haystack. From radio waves to biosignatures, SETI's search is a voyage of discovery. We've journeyed from early attempts guided by the Drake equation, through the surprise of the WOW signal, to the innovative use of optical SETI and fast radio bursts. We've explored the vast expanse of exoplanets and their habitable zones and witnessed the power of collective effort through SETI at home and citizen science initiatives. Breakthrough Listen has widened our scope, and astrobiology has provided a new way to look for life beyond Earth. Yet, the challenges are real and the future is filled with exciting possibilities as we continue to push the boundaries of technology and methodology. The importance of this quest cannot be overstated. It's not just about finding alien life, it's about understanding our place in the cosmos. As we gaze at the stars, remember, the search for extraterrestrial intelligence is not just about finding alien life, but also understanding our place in the cosmos. Stay curious, stay tuned, and remember the universe is full of surprises.